All right, we now go for we now go for temperature, the final, the freezing temperature, sorry. We still do the same things. We still do the same process. Remember that the first thing is to say that delta T, the final, which means the depression, right? We are always just talking about this freezing point depression. What is it going to be equal to? So this freezing point depression, this is going to be equal to Kf times m, because delta T is Km, right? So we are now, this is the first one that we're going to use, right? And now since we already know the molality, it's going to be very simple. Then we'll use again. So we're going to, we don't have to put the box now. Is going to be, what is our Kf? Kf is going to be 1.86 degrees Celsius per molar, okay? 1.86 degrees Celsius per molar. Then we multiply by the molars, right? How many molars did we have? 3.62 molars. So by 3.62 molars, okay? This is a multiplication sign. And remember that this is where I got the 3.62. Then we can be able to get the solution now. First, we'll say what is 1.86 times 3.62. We'll get 6.7332 degrees Celsius. Okay? Which, if you want to put to three significant figures, we'll just say 6.73 degrees Celsius. Now, either way, we have this. Then remember what we will now say was delta TF. This is going to be equal to, now we want to find it, the second formula now, so that we can be able to find the freezing temperature of the solution. So what do we say? We know that the freezing point depression, this is going to be equal to what? The freezing temperature of the solvent minus the freezing temperature of the solution. You say to me, how do you know? Well, the bigger one should always come first. We know that when we're talking about a depression here, so that means that when we add the salt or the solvent, the solute, when we add the solute, something that's going to dissolve, is going to reduce the freezing point. So it's lower. So it's the one we write second. The solution comes second. So this is going to be, what is the freezing point of water? We have to know it, 0 degrees Celsius. Just like we were not given the boiling point. Okay, this temperature of our solvent, this TB, the boiling point temperature of our solvent, we will not be given the freezing point temperature of the solvent, but we know because our solvent is water, the freezing point is 0 minus this that we would we have to first take it to the other side and say delta TF. What we want is we want for the solution to be alone. So I'm going to take solution to the other side because it's negative. So it's going to end up being TF solution. It's now positive. This is going to be the temperature of the freezing point of the solvent, then minus the change in temperature, the freezing point depression rather. So this is going to be the temperature of the solvent. The freezing point temperature of a solvent is 0 degrees Celsius, it's water, minus this is going to be 6.73 degrees Celsius. And we'll get it being negative 6.73 degrees Celsius. So this is going to be the temperature of the solution, the freezing point temperature. It has been reduced to negative 6.73. And you will be done, okay?